get the camera going. Just wanted to summarize some of the things that we spoke about so that we can understand and get a pretty good grasp of what has to be done here. Again, my name is Walter, and I'm with the company called In God's Lap, because that's where we are. We talked about rivet sets. We talked about clecos and cleco pliers. We talked about rivet squeezes, dimplers, and the reason why sheets are dimpled, especially when they are too thin to countersink or to remove material to allow a rivet head to sit flush with the sheet. We talked a little bit about the rivet alloy and the sheet alloy, which is most typically used around aviation. If it's a aluminum aircraft, and probably 90% of the aircraft out there are aluminum, although more and more aircraft are being made with composites or with fiber, carbon fiber, fiberglass and things like that. And the normal type of aluminum is a 2024 alloy. That's a copper-based aluminum alloy. We didn't speak much about cladding or the rolling of a protective coating of pure aluminum onto the sheet, although it was mentioned a little bit earlier in another segment. Cladding is protecting the sheet from corrosion normally, and is easily damaged by scratches or mishandling of sheets prior to or during construction or during the service life of the aircraft. So cladding is to be protected. If a scratch occurs in the cladding, then the sheet below it is open to the environment, and cladding is used as a protection against corrosion. Aluminum, although you might not realize it, or sheets of aluminum, just like wood. You see a wood grain in the wood, and if you noticed or have been told, or if you are experienced with wood and forming wood or breaking wood for that matter, it's easiest to break wood when you are breaking it parallel to the grain, and harder to break it when you're going across or perpendicular to the grain. Aluminum is just like that. There is a grain. So when aluminum is formed or bent in a break, a bending break, or when it is bent around a sharp edge, it is better to bend it perpendicular to the grain rather than parallel to the grain, or any way possibly away from parallel to the grain, even though you might be at an angle to the grain rather than at 90-degree angle. The sharp object that you might be bending aluminum around also cannot be too sharp. There is a minimum bend sharpness, or they call it a minimum bend radius, that you can bend aluminum around. And when aluminum of a different or various alloys, and that radius does vary based on the alloy of the aluminum. Some aluminum sheets are stiffer, harder, and some are softer, a lot softer. Some are zero hard, and the zero hard ones naturally can be bent around very tight radii. The harder types have to be bent more gradually around a larger circle, and a radius is defined as half the diameter. So a radius is going to be specified in that 4313 advisory circular for the different alloys, and the minimum bend radius is something that you don't want to go below, or else you'll induce stress in the bent section of the sheet. Although you might not see cracking, you might not see any kind of visible evidence of stressing the sheet, you have set up avenues for moisture or different types of contaminants, or even the environment, I suppose, to enter into those stress cracks, which may be minuscule, so small that you won't even know that they're there. And you've also work hardened that sheet in that area if you've overstressed it, so that it will crack easier in operation or in service. And you can have an airplane falling apart doing that. So there is a minimum bend radius specified for different alloys, And when you are forming sheets, you want to make sure that they are formed so that they do mate with the components that they are to mate with, to make sure that that construction is a very tight and strong, continuous construction. So if you are making a channel fit into another channel, there are calculations called bend allowances that have to be made or should be made to make sure that those channels fit one inside the other with very little gap between the edges. If there's a U to be made smaller than another U and they need to fit in and very tightly fit, then they need to match perfectly. And the way to make sure they match very perfect is to calculate their bend allowances of the material that's used up when it is being wrapped around a brake or a bent. There are pneumatic tools that we use. The rivet gun is a pneumatic tool, pneumatic drills, pneumatic presses. As I said before, we have a very small collection of the components that are actually, or the tools that are being used in manufacturing or repair of aluminum structures. There are things like stretchers, form blocks, crimpers, shrinkers, stretchers. I mentioned a slip roll former before and a bending brake. There are rivet spacing tools that do make sure that the rivet spacing is held uniform. And when the rivet spacing is held uniform, then the flexibility of the structure is maintained. So you don't have a concentration of stiffness in one section of an item and then flimsy or looseness somewhere else where you might cause damage or structural failure at the stiffener or stiff part of the structure. Bolts have been substituted for rivets. Rivets are just cheap bolts pretty much. The FAA does allow the substitution of bolts for rivets. If you don't have the right size rivet and the bolt is the right type and grade and is rated for the purpose that it is being used or you intend to use it for, you can substitute bolts for rivets. But again, rivets are a lot lighter and bolts are not normally substituted and made out of aluminum. These rivets, being made out of aluminum alloys, have the same tensile strength as steel or better in some situations. There are a lot of things that you can do to get yourself in trouble, like drilling through your body if you're not watching, or if you're holding some item in your hand, or clothing gets caught in machinery. So you want to be thinking about safety all the time. I'm going to stop now. We'll get back to it later.